morning, good afternoon, good evening. Welcome to the session 3 of our TypeScript bootcamp. Thanks for joining us. And today we are going to create the user interface. We are already expert in creating and testing smart contracts on Algorand using TypeScript, but now we need to build the interface for our dApp. And in today's session, we will learn how to interact with our smart contract from the user interface. And obviously, AlgoKit can help us to speed up this process. Please let us know on the chat if you are ready for the session 3 and who is almost ready to claim the certificate of completion that is going to look like this. So hold on a second, I can share my screen. So these certificates are like Pokemons. You need to claim them all. So this is going to be our certificate. As already mentioned, you can add this certificate to your LinkedIn profile, and this is going to be a credential. And in the upcoming dates, the Gora team is going to create a post explaining the process, why this certificate different from a traditional NFT. So that is the certificate, but you will be able to claim it in tomorrow's session. So we are ready for the content that Joe has prepared for us. And don't forget to share screenshots of the session on your social and tag us. So Joe, we are ready. I really love this session, and I know that we are going to learn a lot.
All right, sweet. Yeah, this is a session where it all starts to come together. And so today, much like our previous sessions, I'll be playing a video and you can ask questions in the question tab as we go along. For those of you that attended the Python bootcamp, the front-end integration process is going to be the same as the Python integration because we're using our generated client. So what we're going to try to do is separate out. So eventually we're going to integrate into React, but we're also going to separate out generic functions from React-specific integrations. So in today's session, we'll be writing generic functions that we're eventually going to use in React. But what we're doing today, you can also leverage it in other frameworks, like you could use Vue or Svelte or any other front-end framework. But we're going to be specifically using React, and in particular, the React template that is provided by AlgoKit. So we'll be leveraging a lot of the code that AlgoKit provides for us that makes our life easier. And by the end, we'll get to see how we can interact with our contract and what our contract looks like from the user perspective. So definitely exciting sessions as developers. You can finally click some buttons and see some things happen.
Absolutely. That is the important part, to realize how you can create a user interface, and in that way your user can start working with your application. So pretty excited for today's session.
So let me see. I don't think we have any questions to start. So yesterday where we ended up is we wrote our tests using AlgoKit utils library, and in particular, the Algorand client from AlgoKit utils and our generated typed client. And we're going to be using those same pieces here today. So what I can do is I will start the video and we can answer any questions as we come in. Now, just to note, technically this video is one long video that will split between today and tomorrow. So roughly the halfway point, once we get done with the generic content, we can wrap up for today. So let me go ahead and find the video and we can get started. Hey everyone, now that we have written our digital marketplace contract and we've tested it, the next thing to do is talk about how we begin to integrate it into our front end. Now, in this specific video, I'm going to be integrating it into a React front end using the AlgoKit template. However, if you don't want to use React or don't want to use the AlgoKit template, a lot of what we go over here, especially in the beginning, is still going to apply to other frameworks. So even if you aren't a React person and you want to learn how to integrate into another framework, definitely stay tuned because we're going to be talking about some general practices about how we can integrate our smart contracts into any front-end code base. So to get started, like I said, we're going to be using an AlgoKit template, just like we did an AlgoKit template for smart contracts. So if you notice, at the very beginning, if you remember, when I did an AlgoKit init, I made a project called Digital Marketplace, and I just did a smart contract, and that project is called projects/digital marketplace. In order to add a front end to my project, what I'm going to do is I'm going to open up the entire workspace in CodeSpace, or excuse me, in VS Code here. So I'm going to, so from the root, I'm going to run code and then go back to directories. And what this will do is this will open up the base directory of my AlgoKit workspace. So because we just did a smart contract, we've only been working in this directory. But now what we want to do is we want to add another project in my AlgoKit workspace. So to do that, I forgot to zoom in on this one as well. So to do that, what I'm going to do is you can see here, this is the directory we were just in. So we were just in projects, digital marketplace. Here's our test, our contracts, all that stuff. And so now, however, if we do an AlgoKit init and we run that, and again, I should emphasize we are in this base repository for a workspace. So we're not in the projects digital marketplace directory. We're in the top level directory here. And you'll know you're there if you see the README and this AlgoKit toml file and the .algokit file here. So if I choose dap frontend, I'm going to just call it frontend. And I'm going to choose the production template. The main difference between production and starter is production has more libraries. Because I'm not a good front-end developer, choosing the production template actually makes it easier for me to make a somewhat good-looking website. So I'm going to do that. I'm going to skip the CD setup for now. And we're going to go ahead and install our npm dependencies. And so what this will do is in our projects directory, it's going to create a new front-end directory. And this is going to be where all of our front-end code exists. And as you can see here, instantiating or creating a bunch of code for us. So before we get to it, let me just let the dependencies install. And again, first time you're running AlgoKit Bootstrap or AlgoKit init, it might take a second to install the dependencies, but afterwards it'll be pretty quick. Okay, and I'm just going to close out of the front end directory because I still want to stay here in this top level for a second. And so what we can see now is in our root workspace, we have our digital marketplace with our contract and our front end, which has all of this React code for creating a simple front end. So now if I go into my front end directory, let me code projects front end. I can close out of this, make that bigger. And what I'm going to do before we get into any code is I'm just going to run, we can make this one bigger, see how that works. I'm going to run npm run dev. And what this is going to do is it's going to start up a front-end project. Or actually, let me go have this screen ready to go. So it starts this welcome to AlgoKit, where we can look at the AlgoKit CLI repo. We can connect our wallet. Right now, because we're on localnet, we're just connecting to our local wallet. And then we can send some transactions. But we're not going to go through that. Instead, we're going to be modifying this template to interact with our digital marketplace. So if I come back here, what I'm going to do is if we take a look and we come, actually, if I do an npm run dev again, and we take a look at one of the steps, is this AlgoKit project link all and it's generating a client for us. And so this is how we link our front end to how we link our smart contracts to our front end. So if I copy that command and just run that independently, so it's a little easier to read the output, you can see what's happening here is that we're generating a TypeScript client code, much like how we generated a client for our testing, except this time, by running project to link all, it's not putting the client in our smart contract directory. It's putting it here in source, contracts, and then here's our digital marketplace client. So it's still using the same client that we used in our testing, but it's automatically linking it to our front end for us. And so this algokit project to link all command is going to be what we use as you iterate on your contract and want to update your front end. You run algokit project to link all, and that'll pull in all of your contract clients. And I say all because one given, so if we come back or take a look out at the projects directory, we could have multiple projects that all have smart contracts, and one of those projects could have multiple contracts. So running link all ensures that our front end gets all of the clients that we want to bring over. Okay, now what we're going to do is we're going to attack this kind of piecewise. So like I said, at the beginning, we're just going to write kind of framework agnostic code. We're not going to be going right into React. We're just going to be writing basic wrappers around our typed client so that we can easily plug it in to a React component that we later create. So actually what I'm first going to do is I'm just going to commit this just so we can more easily see the files that we create. And what I'm going to do, I'm going to come to source. I'm going to create a new file called methods.ts. And what this file is going to contain is, like I said, wrappers around our generated client. So first thing I'm going to do is I'm going to import star as algokit from Algorithm Foundation / algokit utils, and I can't save right away because it'll complain about not being used. And then I am going to import my digital marketplace client from contracts digital marketplace. Okay. Now at this point, I can go ahead and start writing my wrapper functions. But before I do that, I need to quickly do some magic. I'm going to pause the video, make sure I install the pre-release version of algokit utils so it matches the version you're going to have when you first get started. So just give me 1 second. Okay, I'm back. And again, you don't have to worry about what I just. Okay, so I just want to, so in the recording of this video, I had to install the pre-release version, but this version is now released. However, it might not be the version that is used in your template by default. So give me 1 second. And I will get the exact version that you need to make sure you have. Sorry, I forgot to pull up the link before. I just want to make sure I give you the right version number. AutoKit tools. There we go. Okay, so it's 602. So I'm going to paste the command in the chat for what you need to run. Okay, so in the chat is the command for uninstalling algokit utils and then reinstalling it. There is a way to just directly upgrade, but uninstalling and reinstalling is the best way that I found using npm to update your package to the latest version. So what you should see is, let me open this up in this code so I can share my screen and show you what you should see. Okay, so in your VS Code, if you're gonna go to your project's front-end directory. Let me make this bigger. In your project front-end directory, you just need to run npm rm Algorand Foundation / Algokit utils. And then you do an npm I Algorand Foundation / Algokit utils. And to make sure that you're on the latest version, if you come into your front-end directory and you open up this package JSON, we should see here in our dependencies, Algorand Foundation / Algokit utils, and we are on version 6.0.2. So you just want to make sure you're on that version 6.0.2. And later on, when we are writing our code, if you're seeing errors about the Algorand client class, it's because you're not on the latest version. So if you have questions on that, we can come back to this. But those are the steps you need to do to make sure you're on the latest version. And in the future, we'll update the template to use this version so you don't have to do this manually. But for now, just make sure that you've installed Algokit utils version 6. Okay, and what I can do is I think I saw some questions. So if you're seeing two different digital marketplace client TS files, that might be they were generated from different steps. So if you, for example, manually ran the Algokit generate command, it will generate, I forget which one is which, but it'll generate one file name. And if you run it through the Algokit project link command, which runs automatically when you do npm run dev, it'll generate the other file. Both of these files would be or should be the same content though. So they're just generated in slightly different ways, thus they have different names, but the generated client at the end of the day is still always going to be the same, like technically. Yes. So in the init experience, what we did is we first started with init just our smart contract, and then we later did init just our front end. If you chose smart contracts and that front end, it would basically init both for you at the same time. However, in the context of a boot camp, when we're just focusing on one thing at a time, it made the most sense to do the init one at a time. But the code that is generated by Algokit for you is the exact same, whether you do them separately or you choose smart contracts and that front end at the same time. It's just a little bit easier to have less code to work with when we're just getting started with the smart contract, so we did it separately. But the templates are the exact same if you're to do it both at the same time or separately. Okay, I think we're all caught up on questions. So again, just make sure you're on version 6, and you'll know if you're on the wrong version if you start seeing some errors about the Algorand client. If you see that, just post a question and I'll make sure to help you get on the latest version. But should be able to go ahead and continue the video. Back, and again, you don't have to worry about what I just did. It'll be done for you automatically by the time you're watching this video. But because I'm recording in advance, I had to do some behind the scenes magic, but it should be working now. So now I've imported Algokit in my digital marketplace client. I'm going to start writing some wrappers around the methods that I need to actually interact with my contract. So of course, the first thing we're going to do is write a function. It's not going to be async. Write a function called create. And this is going to be a wrapper around our create application function, the function that we call to actually deploy our marketplace. So in here, I'm going to pass in a couple of variables. I'm going to pass in my Algorand client. I'm also going to pass in my digital marketplace client. And here, throughout this code, I'm going to call it DM client. In our test, we just called it app client because we were just testing one app client, obviously. But here in your front end, you don't want to make the assumption that you're only going to be integrating with one client. There, in the future, you might integrate with multiple clients. So it's good to give it a variable name that makes it clear that this is the client for the digital marketplace. And so let me just start with that, and then we'll add more variables or more arguments as we need them. Okay, now in this function, what I'm going to do is I'm going to return an async function. And when we actually get to using it, it'll be a little bit more clear why. But the general idea is that I want to create a function that I can pass to a React component that can then return an async function that we wait and be able to update our UI from. So when I click a button, I want it to show that it's loading and doing something, and that something is going to be defined by the function we return. Right? So I'm going to say, and again, if that doesn't make full sense yet, we'll connect it better how it connects up when we actually get to the React integration. But for now, follow along, and we're just going to create an async function here. And in this async function, again, it's going to be important that this is just going to be no arguments. And it's going to be a void return as well, because this is just going to be a callback function in our React component. So the first thing I want to do is I am going to create my application. So I'm going to call DM. Oh, wait. Why does my thing keep showing up? Okay. Sure, we can get rid of the terminal for now. Await DM client dot create application. Okay, so far nothing new, much like we did before. And if we recall our create application, it's going to take in two arguments, the asset ID and our unitary price. So I'm going to come up here and I'm going to come up here and I'm going to add asset ID. Actually, let me call this asset being sold, just to make it a little bit more explicit. And then I'm also going to add the unitary price. And that is going to be a big int as well. Okay. And so now we can say asset ID going to be asset being sold and our unitary price. Okay, so right now we have this function that if we passed it to a React component with the proper arguments, it would know the callback function to call, or it would call this callback function and create the application. But we need to do a little bit more. So in this example, basically what I want to happen is I want to write this front end to support someone that might not have an asset yet. So maybe they're not coming to the marketplace to sell an asset they already have, but they're coming to the marketplace to sell a brand new asset. And in our simple example, this asset doesn't really mean anything. But in a full stack production app, maybe this asset represents some physical good or some other digital good that's off chain. And so we want a way for people to come to our site and easily be able to create the asset when they create their marketplace. So I'm going to say, let asset ID is going to equal to asset being sold, but I also want to say if the asset ID is equal to 0, then I'm going to create an asset. So I'm going to say const asset create is algorand.send asset create, and I'm going to just match the quantity. So the total is going to be, when we need to know how much we're being sold. So we're going to add a quantity argument here. So our total is going to be quantity. And then we're also going to need our sender to be passed in. So I'm going to pass in our sender here. Okay. So if the user, or if our front end calls this function with an asset ID of 0, we know we have to create the asset for the user, and the total amount we're going to create is their quantity. Now, again, there are many different ways we could implement this. We could ask them also for a max supply and a quantity. We could ask them for more fields to populate the asset with, but we're keeping the code very simple so we can just focus on the smart contract integration. So last but not least, we just need to extract the asset ID from the asset create confirmation dot asset index. Oh, and I always forget to do this. We are going to await. No, it's the wrong spot. We're going to await here, right? So, and we're going to say we know that this exists. And make sure this is lit. Okay, so our function, first off, we're going to assume that our front end, where we're integrating this, knows all this information. We're going to assume that it has an Algorand client and a digital marketplace client. That's going to tell us all the information about the asset that we're selling and who the seller is. If our asset ID that is passed in is equal to 0, then we're going to go ahead and create a new asset for the user, and we're going to use that as our asset ID. Okay, so right now, if all we wanted was a function to actually create the app, then we're good, we're done. However, when a user comes to this site, they don't really think in terms of what are the ABI methods I need to interact with. They're thinking of what are the logical actions that I want to happen on chain. And in the same step that they create the marketplace, they expect to transfer those assets as well. So we could create a separate function that handles depositing assets separately. However, we can do that in our create function because the user would expect that every time we create the app, we also deposit in the assets that we want to sell. So I'm going to come down here. I'm going to say, actually, let's do await DM client dot opt into asset. And in this opt into asset, we need this MBR transaction. So I'm going to create an MBR transaction. And this is going to be the transaction that gives the app address enough minimum balance to opt into the asset. So I'm going to go ahead and say Algorand not send dot transactions dot payment. And here we're going to keep the sender. The receiver we can get from the create result. Create. I need to first create a variable called create result. And the receiver is going to be create result dot app address. And then the amount is going to be algokit.algos, 0.1 algo for the account minimum balance. Again, remember, every account needs 0.1 to start, and then 0.1 for the asset. And then we need to pay an extra fee of 0.001 algos in order to cover the inner transaction to opt in. And now we can go ahead and do the opt-in. Now, what's going to be important here is that we think about what information we need to communicate back to our front end, right? So every time that I deploy a new application, I need that front end to be aware of what that new application ID is. So in order to do that, there's a couple ways we could do that. But in order to do that, and particularly in order to do that in a way that is compatible with React, I'm going to make a argument here called setAppID. And this is going to be a React useState function. But for now, we could just say it's going to be any function that takes in a number and returns void. Now that we have our setAppID function here, we're going to use that at the very end of our function to setAppID. This is going to be the number of our create result dot appid. Okay, so this is going to be the main difference between how we integrate for testing and how we integrate for our front end. For starters, obviously, we can't assume we know what account we're going to be using because the user is just going to connect their wallet. But also, when we're testing, we are testing each function individually. However, when we're integrating it in our front end, the users don't care about how things are implemented as ABI methods. They just care about the actions that take place. And so we can logically group together our create of our application and our depositing. So we're going to take care of the opt-into asset and the create in one single button click. And one thing I forgot to do here is I'm going to say also await algorand.send asset transfer, and we're going to transfer over the asset ID to the app address. And our amount is going to be quantity. Okay. So in our test, we just did our create and our before all, and then we tested opt-in and the transfer separately. But we can do that all together here because that's basically what the user would expect. Okay, so we have this create function. Now what I'm going to go on to is our next function, which is going to be for buying. So we're going to follow the same exact pattern. We're going to have a outer function here that returns an async anonymous function. And we're going to start off with the same basic thing. So our algorand and our DM client. And now for our buy, what we can do, and we also need to specify our sender. And for our buy, what we're going to do is we need to construct the payment. So much like in our test, we're going to have a buyer transaction. This is going to be an algorand transactions payment. Sender, the receiver, is going to be our app address. And so that is going to be another argument that we pass here, app address string. Receiver is going to be app address. The amount is going to be algokit dot micro algos, and we're using micro algos because our unitary price is in micro algos, and micro algos expects a number, so we're going to take our quantity. So another argument that we have to add here, quantity is going to be a big int, quantity times our unitary price, and that is going to be yet another argument that we need to pass in. And again, right now we have to manually do conversion between number and big int. In future versions of AlgoKit, it'll be able to handle this much better, and everything will be able to handle big ints. So you might not have to do this in the future, but we do at least right now. And once we've formed our buyer transaction, we can just call DM client dot buy, and we can pass in our buyer transaction and our quantity. Okay. And now, one thing we want to do is we also want our app to be able to keep track of our state of the application. So, we want our front end to be able to keep track of the state of our application. In particular, we want our front end to know how much is left in our contract in our marketplace. How much is left to be sold? Now, we could do this by having a timer that continuously watches the chain and updates our front end. However, to keep things a little bit more simple, we're simply going to report back the amount left every time we do a sale. So to do that, we're going to read state from our contract. Again, much like we did in our test, we're going to await DM client, get global state, and then info is going to be await algorand.account.get asset information. And what we're going to do is we're going to pass in the app address and then our state asset ID as big int. I'm going to assert that that is known. And then we're going to have a callback function, much like we did before, set units left. And this is going to be a callback function that takes in a big int. And we are going to return here void. I'm going to call set units left info.balance. Okay. At this point, we've gone ahead and we have made sure that all of our functions for both create and buy are covered. However, we still have one more function that we need to get to. In order to implement our delete function, we're going to expose another function, export function delete app. And again, we're going to follow the exact same pattern. We're going to return an async function here. And give me 1 second. I have my cheat sheet here to make sure that I am not forgetting anything. Okay, and this is going to be very simple. We're just going to call await DM client. Oh, we need to pass in our Algorand client and our DM client. We're going to await DM client dot delete application. And then one thing we're also going to do here is we're going to pass in a set app ID function. This is going to be able to take in a number and return void. And then we're going to call set app ID to 0, right? So again, much like in create, we want our front end to know when we've created the app, what the app ID is, and when we delete, we want our front end to know that we've deleted and we can set the app ID to 0. Okay, so at this point, this is basically all the code that we're going to be writing for actually interacting with the app. Everything from this point on is going to be implementing it in React in the AlgoKit template. So if you aren't using the AlgoKit template or you aren't using React, you can kind of stop here. However, if you want to see how I actually take this into React, then we can continue on here. Okay, so as I mentioned, this video is a bit longer and we're gonna split it up between the 2 days today. And this seems like the logical splitting point. We still have about an hour left that we're gonna cover tomorrow. So today's session, we're ending a little bit shorter than usual. Tomorrow's session might go a little bit longer than usual, but this seems like a good logical place to stop. So at the end of today, like I mentioned in the video, what we have here is basically a framework agnostic wrapper around our typed client. So AlgoKit was able to generate us was able to generate us a typed client that we can use to easily interact with the contract. And then we just wrote some wrapper functions to properly use that contract in the context of our front ends. And so now that we have the groundwork laid down, tomorrow we can go ahead and just focus on React and plugging those methods that we wrote today that leverage the type client into our React framework. And of course, if you wanted to use this same concept in a different framework, you could do that as well. And let me see.
We have one question, Joe. Okay, that one.
Yeah, so yes, on Algorand, we support, of course, you can deploy contracts on the network, but you can also delete contracts as well. Now, when you're writing a contract using Python or TypeScript, by default, it is immutable. So you can't update it and you can't delete it. However, we specifically wrote a function for deleting our application, and this means we can delete the app from the blockchain. Now, when we delete the app from the blockchain, that means that no one else can call the app, and any funds that were in that app's address are now essentially locked. And because the contract doesn't exist, it can no longer spend from that account. So we are deleting it, and that is a native feature of Algorand. Of course, if you had a full archival node, you could look at the chain history and see the app and all the transactions that were made to the app before it was deleted. But by deleting it, we're making it so that no one else can call the app. And the reason why we delete apps, A, to prevent people from calling code that we no longer want people to call, but B, this also frees up the algo that we had to lock when we created the app. So, and we covered our, when we covered our content in that intro bootcamp, we discussed, and we covered a little bit here in the beginner as well, this concept of minimum bounce requirement. And the idea is that every time you do something that adds to the size of the chain, you need to lock algo in your account. And that includes to when you deploy an application. So when I create an application on the chain, I have to lock algo in my account. And when I delete it, I get that algo that was locked back. So there's an incentive to delete applications that no longer need to be used. And this helps you get your algo back and also helps keep the chain from growing too quickly. So that is why we are going to be deleting our app. And looks like there's another question. So the local environment that we get from AlgoKit LocalNet Start, it is a full archival node in the sense that all the transactions you do locally, you can have a history of. However, it's not connected to any network. So when we do a local kit or AlgoKit LocalNet Start, we're starting from our own Genesis block, our own block 0. We aren't connecting to mainnet or testnet at all. So locally, we don't have access to the full history of any other network other than everything we've done on our own local machine. If you wanted to, you do have the option of running your own node. Of course, anyone can run a node and you can make that archival and you can connect the indexer and do all that. But by default, when you delete an app, by default, when you run a local net, it's just its own siloed network, not connected to anything else. And if you're, maybe you can clarify what exactly references you're referring to, but in general, when you delete an app, it shouldn't be fully deleted from like the indexer. Actually, now that I think about it, it is a configuration setting, so LocalNet might not show deleted apps by default. But either way, you could still look at the chain history and see the apps if you wanted to. You just might not be able to go to an explorer and see them, but they still exist in that history of transactions. You can see that, in block whatever, I created created an application, and then in some following block, I deleted. So you still have a footprint of that stuff happening. It just might not be accessible directly, like through an Explorer, for example. And yeah, so clawback, it allows any account to basically move the asset from any other account. So if I am the clawback address for an asset, I can take that from anyone's account. This is a completely optional feature on assets. And it also is, so if you create an asset with no clawback address, it is impossible to add a clawback. So you can't, buy an asset thinking it can't be clawed back, and then you find out later on it is clawed back. Once an asset has no clawback, that can never be changed. However, if an asset has a clawback address defined, there's also another special address called manager that can change the clawback account. So what you want to do as an end user when you're acquiring assets is you want to make sure that you check the clawback field. If it's not defined, then you have nothing to worry about. But if it is defined, you want to check the manager as well and make sure that your assets can't be taken. But I should mention that clawback and also freeze, which allows you to freeze the asset, are very useful functions in regulatory context. So for example, USDC, Circle will not deploy USDC on chain if it doesn't have the ability to get frozen. So this is a very important feature for like stable coins, for example. So completely optional feature. If you don't use it, it's immutable. So you never have to worry about like someone rug pulling you in the future. But it is exactly as you described. You can take it from any account when they want. And it doesn't have to be an end user account. It could be a smart contract. So you could see that, maybe the clawback address is a smart contract that only claws back under certain conditions. So you can have a lot of programmability with these native features. Yeah, and then this is a great question about app IDs, and asset IDs work the same way as well. So how the asset ID and app IDs get the numbers is they just use the transaction counter. So for every transaction that happens on chain, we increment the transaction counter by 1. And when I create an asset, it just takes a look at what the transaction counter currently is and then sets that as the ID. So if 1,000 transactions had happened on my chain, then the asset ID is going to be 1,000. Or actually, it'll be 2,000 because the transaction counter starts at 1,000 for historical reasons. But the general idea is that every transaction increases the transaction counter. Thus, every app in asset has a unique ID. So once you delete an app with a specific ID, that ID is off the network. It can never come back. That being said, we also have native support for updating contracts. So if you wanted to have a constant app ID but change the logic, you can do that. But once you delete it, you can never get that ID back. And that works for both applications and assets. They both use that transaction counter to get their ID. And this also makes it impossible to, or at least very hard to predict what your asset ID is going to be. So before I actually create an asset, I can have a rough idea of the range that the asset ID will fall in, but its exact ID is going to depend on the block ordering. So it's non-deterministic. And for checking clawback freeze, I mean, as a end user, you can on explorers, most explorers will show this information. Okay, let me see if I can. Okay, so if we take a look here, so this is using allo.info, one of the explorers we have available for Algorand. And we can take a look here. This is the NFT that I use for my profile picture on Discord and Twitter. But we can see here, there's this related addresses field, and you can see who created it, who the manager is. So the manager has the ability to change all of these fields. And then what the reserve, the freeze, and the clawback are. And in this case, the freeze and the clawback are not set. So I know this token can never be frozen or clawed back. Now, from a developer perspective, what you can do is you can use our get asset information SDK call, and that will basically return all of these fields in a JSON structure that you can then check the reserve, clawback, or freeze. And you can also do this in a smart contract by comparing these fields to the global 0 address. So on chain, if something is not set, we don't have a concept of like undefined. It would just be equal to the 0 address, which is a special address that no one has the public key to, and it signifies that that field is not set. So depending on the context of whether you're a user, developer, front end, or smart contract, there's always a way to check this field and be sure that it is or isn't set. And we got one question about eSupport users to create apps in the wallets. Is there an Algorand wallet with this support? So if you mean like a UI for creating your own application directly from the wallet, there aren't any wallets that support this as far as I know. But all the wallets support signing transactions for creating an app. So if you're using a dApp that has you create an app, you of course can sign that transaction in your wallet. But there isn't like a UI in the wallet for manually deploying an app, mainly because there's a lot of different, possibilities for apps. So it'd be hard for a wallet to integrate like a seamless UI that kind of covers all the main use cases. So, and because our tokens, for example, which is a common use case for users minting, are native assets. So we don't need to manually deploy smart contracts for things like tokens. Just getting caught up on the chat. Yeah, I think we've covered all of our questions. Yeah, exactly. And normally, like user-facing products will warn you if you're interacting with something that's clawback or frozen enabled. So as a user, you'll always be aware.
Yeah, and that is an interesting feature that can allow you several use cases. So it depends of the thing that you are building, you can enable the freeze and the clawback. For example, if you are selling memberships and in some way the user is in a bad way, you can clawback or freeze that asset. Awesome. So thanks, Joe. Today we learned how to set up everything to be able to interact with our user interface. And I'm really impressed by how AlgoKit utils make our life easier, because there are too many things that before AlgoKit utils you need to do by your own using the SDK. But the purpose of these bootcamps is through a project to show you the latest in developer tooling. And we want this content to serve as a base for you to build your own project. And we are almost ready to participate in the hackathon with all the things that we have learned during these 3 sessions. So the next step and the invitation is that you can participate in the hackathon. If you want, I can share you the registration link once again. And thank you all for joining us today. I don't know, Joe, if you have any additional comment or something to mention before we end today's session.
No, I think that covers it for today's session. Looking forward to tomorrow when we can finally see it visually. I think if I can remember to do this tomorrow, what I'll do is I'll show you what the end product for a front end looks like, and then we'll go into building towards that. So looking forward to tomorrow.
I know it. So thanks, everyone, and see you tomorrow.
Bye, everyone.